Bismillahirrahmanirrahim. We are studying Chapter 8, that is Automatic Transmission and the Transaxle Principle. Today, finally, is the last lecture of this chapter. So, as you know, when we are covering the last portion of that chapter or that topic, I usually give the recap of all the slides of this chapter which we have studied. So let's see what we have studied in this chapter. So as you know, this is our basic slide of this course. The powertrain oblique power flow of a rear wheel conventional four drive rear wheel conventional vehicle in which we have our engine power where the power is developed, the flywheel power goes to the flywheel, clutch, gearbox, transmission, propeller shaft, and differential box. So the extra topics which we have studied, the brake, suspension, steering, and we are now studying the second last chapter of this course, that is automatic transmission. Then we will study the hybrid vehicles. So this was the basic slide for this chapter. We have engine here, then we have this flex plate, then we have this torque converter, then we have this automatic transmission, which is a combination of the pump, hydraulic pump, and the clutch packs and compound planetary gear sets. And then we have this output shaft, and then it goes to the drive shaft, oblique slip gears, and the housing and all the hydraulics involved in this. Then we have studied these part of the automatic transmission, that is torque converter, planetary gear sets, pumps, multiple disc clutches, brake bands, and overturning clutches. Now, first we have studied the torque converter. The torque converter torque converter is located between the engine and the transmission oblique transaxle and performs the following functions. We know that transmits and multiply engine torque, act as clutch between the engine and transmission oblique transaxle, allows slippage, which makes it possible for the transmissions to be engaged in a gear even when the vehicle and wheels are stopped. Parts, there are three major parts: the impeller, the turbine, and the stator. We have studied in detail what the impeller do, what the turbine do, and what the stator do. Then this was the figure of a torque converter of a vehicle. Then this was the functional diagram of how the impeller, pump, turbine, and stator works. And this was the example given by a fan, two fan, one is stationary and one is rotating, and how it affects on the stationary fan. Then the flow movement in the torque converter, from the turbine blade, it goes to the stator, then it goes to the impeller, and how it transmits. Then we have a function of the split rings and vanes, how they induce turbulence and circulation of the flow. Then we talk about the torque converter flex plate, which is the first part, which is in between the engine and the automatic transmission. Then few words about the flex plate. Then we have studied the types of flow, which is in the torque converter. There are two types of flow, that is rotary flow and the vertex flow. And when we have studied when we have a rotary flow and when we have a vertex flow. Okay. Now the pumps which do the all the supply the fluids in the automatic transmission, the torque converter. We have studied about this. Then the torque multiplication phase, how the torque is multiplied in this torque converter. So we have studied in this slide. Then in second part, we have studied about the lockup torque converters, the purpose, the function, and how the slippage is there, and how to reduce that slippage, and the uh, torque converter clutch is used for to avoid that slippage. And torque converter clutch operates under following condition. It depends upon your pedal, how much the speed which you are giving to the vehicle, and then how it works. Then we talk about the Prandtl. P is your parking, R is your reverse, N is your neutral, D is your drive, and then it is second, uh, it's a full power drive, then it's a low, and then it's a more low drive. Then we talked about the planetary gear sets. The major parts of the planetary gear set is the sun gear, then we have the pinion or the planet carrier, then we have the outer ring gear. And then we studied about the purpose and function of the planetary gear set, how they perform the function in an automatic transmission, in which the one member is being driven, the other member is held, and the third member where we get the output. Then we studied the different combination and the different figures, and how the torque flow through the planetary gear sets. And this was the basic chart for in which we have studied different combination. If we hold the sun and we give the input to the planet carrier and takes the output from the ring gear, and vice versa. So there are 6 normal cases in which we get the different types of torque and speed, and then we have a max 1:1 and neutral case also. We have studied this thing, and this was the examples given, and same chart with, and then the number of teeth on a planetary gear set is equal to the number of teeth on a sun gear plus number of teeth on a ring gear. That determines the ratio in which they are moving. Then in next part, we have studied about the planetary gear set. That is the different types of planetary gear set. That is Simpson gear set, Gravinax gear set, and Planetary gear sets. We have studied in detail the Simpson gear sets, Gravinax gear set, and the Planetary. Then we talked about the non-planetary gear automatic transmission, which we used instead of the planetary gear set. We use different types of mechanism for the automatic transmission system. Then we talked about the first clutch and the second clutch, how they perform, and third clutch and fourth clutch, different types of clutches used in the manual gears to perform the automatic transmission. Then we have studied the CVT, the constant continuously variable transmission, and we have studied it's the drive ratio and the purpose and the function, and the pulley arrangement. 2 types of pulley, one is larger, one is smaller, or one is wider, or one is smaller in diameter. Then we have studied the parts and operation of the CVT. Then the continuously variable transmission, the input shaft, the drive pulley shaft, driven shaft, pulley shaft, and the secondary gear shaft. We have studied this thing. Then we talked about the dual clutch automatic transmission. It's how it's the advantages and the disadvantages, and what are the importance of these dual clutches, in which gear of the first, third, and fifth, and seventh. The larger clutch is operating, and the smaller clutch is operating the second, fourth, and sixth gear. So this is the diagram which shows the smaller and the larger clutches. Then in next parts, we have studied the hydraulic components and the control system. We have talked about the automatic transmission fluid and the basic types of automatic transmission fluid, what properties it should have to use in the automatic transmission system. Then we talked about the intercooler or the cooling arrangement in the automatic transmission, because the fluid, when it's in contact with the moving parts, it gets heated. So we have to cool down the automatic transmission fluid within its operating temperature range. So you will need to have that cooler, the radiator inside. So this was the cutaway model for that. Then how the automatic transmission fluid cooler works in the system. Then we talked about the pumps, different types of pumps we used. Then the pressure regulator, the valves, how the pressure regulation is worked with the help of the pumps. And then we talk about the vane pumps and how it performs function. Then we talked about the solenoid pressure control solenoids, electrical connection, how it engages and disengages with the help of powertrain control module or transmission control module. Then we talked about the brake bands, which plays an important role to holding the planetary, which holds the planetary gear sets in one of the member of the planetary gear set, either the sun, the blunt carrier, or the ring gears. These are the different types of the brake bands which we have studied. Then the hydraulic servos, which plays an important part in the planetary gear sets, and type hydraulic servos along with the brake band in the combination which we used. Then multiple plate clutches. Instead of single plates, we have used multiple plate clutches. One is steel plate and one is the friction plates, and we used in combinations. So there are different numbers, types of different quantity of steel plates and the friction plates which we use, that is multiple plate clutches, and we have studied what the friction plates do and what the steel plates do. And in normal, the latest, we have one side the friction plate and one side is the steel surface. So these are basically the parts of the multiple plate clutch. Then clutch operation, how it performs and how it operates. We have studied this thing, the different diagram of a multiple plate clutches, illustrated diagram, and this was the uh, detailed diagram, how it looked like, brake bands. Then we talked about the accumulator, which we are used in a cushion or damper of the applying force during the shift. Then in next part, we have studied the valve body in which different valves are located. So this is the valve body which we have studied, and different types of passages, fluid passages are there. These warm work, various transmission holes are casted into them. These are sometimes called worms or holes, worm holes. So every wall body has different worms holes or walls which are operated by the fluid hydraulic pressure, and then we have electronic solenoids which makes the opening open and close. And this was the typical upper wall body showing the fluid passages, wormholes. These are the wormholes. Then we talk about the electronically controlled automatic transmission using the solenoid. These are the solenoids which are used, which are electronically controlled to maintain the line pressure in the switches or in the wall body. Then the types of the wall body, these are the 5 types of the wall body: flow directing valves, one-way valves, check valves, orifice, and manual valves. Then we talk about this check valve, then the manual valves, and then this was the transmission range switch and the shifter cable. And these were the sensor, input sensor, and output sensor, and range sensor, and solenoid controls. And then we have the electronically controlled transmission. This was the previous lectures which we have studied. Now today's lecture is basically basically on the input and output sensors which are used in the automatic transmission system. So let's study that. Now the input sensors. First is the transfer range switch. This sensor is used by the powertrain control module to detect the gears being commanded by the driver. If a reverse or a manual forward gear is selected, then higher pressure line will be needed and the shift will be delayed to provide more power being delivered to the drive wheels. Okay, so this is the transmission range switch. As we have seen in this figure, this is the transmission range switch. which is located beneath the transmission in the lower part of the vehicle. So this sensor is used by the powertrain control module to detect the gear being commanded by the driver. If reverse or manual or forward gear is selected, the higher line pressure will be needed and the shifts will be delayed to provide more power being delivered to the drive wheel. So this we have seen in the figure. This was the transmission range switch, that is the input sensor. Now the engine speed sensor or the engine in speed. The speed of the engine has a direct relation to the amount of the power the engine developed. The developing engine speed information is taken from the crankshaft position sensor. So the engine speed is directly determined from the crankshaft position sensor and is used by the powertrain control module or transmission control module to control shift points and to regulate line pressure. So the engine speed sensor is mounted on a crankshaft position sensor from where it senses the engine is rotating at this much RPM. So that RPM, that info is given to the powertrain control module or the transmission control module. So that's how there is a match between the engine speed and the speed range in the automatic transmission. Then next is the throttle position sensor, TP sensor. This sensor is used in the powertrain control module to detect the throttle opening being commanded by the driver. So everything is depend upon the driver throttle. So if he gives the more throttle, it means we require a more power. More power means more air fuel mixture. When more air fuel mixture, more power, so you require a more speed. So you require a more planetary gear system. The automatic transmission has to work in a higher speed range so that the higher throttle opening means that higher line pressure will be needed and the shift will be delayed to provide more power being delivered to the drive wheels. So this sensor is used by the powertrain control module to detect the throttle opening being commanded by the driver. A higher throttle opening means that the higher line pressure will be needed and the shifts will be delayed to provide more power being delivered to the drive wheel. Now the next sensor is manifold absolute pressure sensor, MAP sensor. These are almost a little bit similar as we have studied in the engine, our engine course, in which we have the input sensors for the that control module, power control module. So manifold's absolute pressure sensor, the MAP sensor. This sensor is used by the powertrain control module to detect the amount of load on the engine. So this sensor is used to detect the amount of load on the engine. The greater the load, the more fuel that needs to be supplied. So if the greater is the load, so it means we require more power. So more power means we require more air, more fuel. And the greater the amount of the power the engine will create. This signal is used to determine the best shift point and to regulate the line pressure. So because of this manifold absolute pressure, the MAP sensor, the signal is used to determine the best shift points and to regulate the line pressure so that we should have a matching arrangement between the engine and the transmission, and we should not observe or feel some jerk in the shifting. Then we have a mass airflow sensor, MAF. This sensor is used by the powertrain control module to detect the amount of the air entering the engine. So how much air is entering in the engine? So this mass airflow sensor gives you that information. The greater the amount of the air, we require more fuel that needs to be supplied, and therefore the greater the amount of the power the engine will create. So if we are getting more air, so it requires more fuel that makes a complete homogeneous mixture. So it should have a complete homogeneous mixture to have a more power. This signal is used to determine the best shift points and to regulate the line pressure. So all these sensors, input sensors, the mass airflow sensor, manifold absolute pressure sensor, the throttle position sensor, engine speed sensor, transmission range switches, They are providing the input to your powertrain control module. So that powertrain control module then senses it and then performs the function. Then next is the speed sensor. These sensors measures the speed of the input shaft and the output shaft, or sometimes other shafts in the automatic transmission or transaxle. So as we know, there are one input shaft and one is the output shaft in transmission, automatic transmission or transaxle. So these speed sensors measures the speed of the input shaft and the output shaft, or sometimes other shaft speeds in the automatic transmission or transaxle. The output shaft speed sensor is more often used to provide vehicle speed information to the powertrain control module and for adaptive learning and self-diagnosis. So this is like this. We have seen this figure. The next sensor is the transmission fluid temperature sensor, the most important. This sensor is used by the powertrain control module or transmission control module to detect the temperature of the automatic transmission fluid, which is present in the automatic transmission. This signal is used to determine the best shift points and to regulate line pressure. It will cause the PCM or the TCM to engage torque converter clutch sooner and disable overdrive to help reduce the fluid temperature if it reaches higher than normal. So basically this temperature fluid transmission fluid temperature sensor, TFT, this sensor is used by the PCM or the TCM to detect the temperature of the automatic transmission fluid. This signal is used to determine the best shift points and to regulate the line pressure, which is desired to be maintained in the planetary and the valve train mechanism. It will cause the powertrain control module or the transmission control module to engage the torque converter clutch. So there should be less slippage sooner and disable overdrive to help reduce the fluid temperature if it reaches higher than normal temperature limits. So these were the input sensors. Now we will talk about the output sensors. Now the pressure control. The powertrain control module or transmission control module controls the line pressure by changing the signal to the pressure control solenoid. So whatsoever input we are getting, it is processed in the PCM or TCM, then the output signal is given to the line pressure by changing the signal of the pressure control solenoid. Using the input signal to detect the condition that the vehicle is being driven, the specified line pressure is commanded to provide smooth shift without slippage. So the pressure control sensor output sensor is basically maintaining the pressure with the help of the solenoid valves so that the required amount of line pressure is maintained in the system so that we have a smooth shift without any slippage. Then next is the shift control solenoid. Shift control is when the power range in your transmission. We have power range switches that is basically from the shift control solenoid. The power control module or the transmission control module controls the shifting by applying power or ground to the correct control solenoids at the right time. Then we have a torque converter clutch. The power control module or transmission control module controls the application of a torque converter clutch by applying power or ground to the correct control solenoid at the right time. So basically this sensor provides the line pressure applying at the proper time to get the power or ground it to correct from the correct control solenoid at the right time. Then after these input and output sensors, then we have adaptive learning. The most late model electronically controlled automatic transmission transaxle use the power control module or transmission control module to monitor the time it takes to complete a shift. That is the adaptive learning. The PCM can determine this from the comparison between the engine speed and the output speed sensors data. So basically due to the help of the adaptive learning, the power control module and can determine this from from the comparison between the engine speed and the output speed sensors data. It, it compares them and monitors them. When a shift is commanded, there should be a change in the speed of the output shaft. So when the shift is commanded, there should be a change in the speed of the output shaft. If the change in the speed is longer than normal, which could indicate normal wear in the clutch pack, the powertrain control module can learn from this and start the shift sooner to allow time for the clutch to be fully engaged. So if the change in the speed is longer than normal, which controls indicated normal wear in the clutch pack, the powertrain control module can learn from this and starts the shift sooner to allow the time for the clutch to be fully engaged. Now, shift solenoids, which we are using in this whole electronics or adaptive learning or this input and output sensor, all the signals goes to the solenoids. Those shift solenoids controls the pressure force, which in turns controls the position of the shift valve. So these shift solenoids basically controls the pressure force, which in turns control the position of the shift valve. A default or limp-in gear is the forward speed, and that is used if there is a failure in the electronic or computer system. A default or limp-in gear in the forward speed that is used if there is a failure in the electronic or computer system. If neither solenoid is engaged, then either second or third gear is actuated. So if we have this failure, then neither solenoid is engaged, then either second or third gear is actuated, depending on the exact make and model of the transmission axle. Now we'll see this chart from the book. For example, of two General Motors transmission solenoid used in electronically controlled automatic transmission. Let's see the chart first. So basically, this is your General Motors 4T60-E front wheel drive transaxle. We have a gear range first, second, third, and fourth. We have a solenoid A and solenoid B. In this combination, both are in first gear, both are on. In second gear, A is off, B is on. In third gear, A is off, B is off. In fourth gear, A is on and B is off. Now, if charts in this example, the vehicle would start out and remain in the third gear if there was a fault with the computer or a wiring. Now, in this case, we have a gear range first, second, third, and fourth. Solenoid A, solenoid B. First is on, solenoid A is on, solenoid B is off. Second gear, solenoid A is off, solenoid B is off. In third gear, solenoid A is off, solenoid B is on. In fourth gear, both is on. In this example, the vehicle would start out and remain in second gear if there is a fault with the computer and a wiring. So this is how it's like this. Now let's see the solenoid used in the electronically controlled automatic transmission transaxle. There are two types: on-off solenoids and linear solenoids. On-off solenoids, these can be normally open to fluid flow or normally closed to block fluid flow. So on-off solenoid, which we are using in the shift solenoid, these are basically which normally opens or close the fluid flow. They are commanded on or off by the powertrain control module or the transmission control module. The resistance of most on-off shift solenoid is 10 to 15 ohms. Basically, we gives a resistance of 10 to 15 ohms. The plunger moves and it is switch on and off the valve fluid, which is fluid flowing from that valves. Then linear solenoid, this type of solenoid can be varied by changing the amount of on time to precisely control the fluid flow through the solenoid valve. So basically this type of solenoid can be varied by changing the amount of on time to precisely control the fluid flow through the solenoid valve. The variable power or ground applied to the linear solenoid is pulse width modulated and allows the powertrain control module precisely control over the shifting and the fluid pressure. So basically, the pulse width modulation, with the help of this and the powertrain control module, we apply a specific pressure at a specific time in this linear solenoids. The resistance of more linear power pulse width modulated shift solenoid is about half of the on-off type and ranges from 4 to 6 ohms. So we require less resistance to operate in this linear solenoid valve as compared to on-off solenoid valve. So this was the the electronically connectors to the vehicle computer coils. These are the coils which engages and disengages the solenoids. The shift solenoid movable core. So these are the shift solenoid movable core. An example of solenoid valve installed in a valve body assembly. So this was the total chapter regarding the automatic transmission system. For my students, I gave some interesting examples. So this is one of the very interesting example of a transmission of a tank TATUD or tank Al Khalid. So let's see, let me explain this figure. On this side, we have an engine, and from that engine, the output shaft or crankshaft, this is coupled. This is the input shaft. See, let this input shaft is coming right up till here. So this is your first planetary, this is your second planetary gear set, and this is the ring gear. Then we have this complex carrier here, then another planetary gear set, and other planetary gear set, another planetary gear set. So we have four, almost one, two, three, four, and five planetary gear sets here, and these are the different clutches which are used in this transmission, and then goes to the this is your final drive, and from this final drive the power goes to the sprockets which moves the tank of a tank. Okay. So this is just for giving you some how the different combination of a planetary gear set along with different clutches can have a different set of powers with respect to the range which we are using. This is just to give you an idea. And how it look like. This is the actual figure of transmission which is used in tank Al Khalid or tank TATUD. Now, another interesting example. Excellent. Have you heard about the tank M47, M48? The transmission drive which we used in those tanks was the cross drive transmission, right front view. So let me explain to you. On this side, we have engine. From engine, the power is coming from this input shaft and going inside. So basically, this is input driven bevel gear, and this is the input shaft, and this is the transmission right housing, and this is the left housing, and these are the right output flange, and here we have the left output flange. And basically these are the steering valve body and the converter oil filter and the range control valve body, speedometer, drive control, left. Basically these are the lifting hooks. These are the mounting flange on where we flange, and these are the walls body which we are. So how it look like. So this is how it look like. So the power is coming. This is your engine. From engine, the power is going to the input shaft. That is your input shaft. Then this is your input bevel gear. From that bevel gear, it is going to the lockup clutch, and this is your torque converter. From this torque converter, it is going to the different set of planetary gears, and this is the steering gear mechanism. Okay, this is automatic transmission or transmission planetary gear system for the gearbox, and this is for your steering clutch. Okay, if you have to steer the left and right. The beauty of this transmission is that it do a pivot turn, not a skid turn, it do a pivot turn. So it's 180-degree it turns on a very same location. If we have to turn a tank or a armor vehicle, then it has to skid and make a radius skid, turning radius. But in this, by using this type of cross drive CD850, the beauty is this: we don't make a turning radius on the very same location. It's turn 180 degrees. So this was the total lecture regarding the automatic transmission. This is just for interesting thing for my students. Now, there is a slight change. Previously, there was some other email address was there, but now if you want to contact me, you can have this email address. This is valid email address. The other email address has been blocked, so you can email me or inbox me in this email address. So thank you very much for your patience and listening. Do subscribe my channel. Thank you very much.